Greetings and welcome to a ramble. Today we're rambling about the department's paper 1 from November 2023. We're looking at question 10.3. 10 learners stand randomly in a line, one behind the other. Yeah. Oh my goodness. Sorry. Okay. In how many different ways can the 10 learners stand in the line? Okay, so there's 10 slots. Available in the first position, we'll have 10 options. We'll have 10 kids to choose from. In the second slot, we'll have 9 options because one will already be standing in the first position. Then the next slot, we'll have 8 kids to pick from, etc. So all in all, we have 10 factorial options, arrangements, right? And this is a situation where the order does matter. So if I have Billy, alphabetical order. If I have Allison and then Billy and then Christy and whatever, if I just swap Billy and Allison and keep everything else the same, these count as 2 different arrangements. So the order does matter, meaning that, we have 10 factorial arrangements. We don't have to think about, but what if these ones swap? Isn't it still the same? It's 10 factorial arrangements. I don't know what 10 factorial is. I don't even know where to find the factorial sign. Jeez. Where are you now? Where are you now? Okay. There we go. Okay. So that is 3,628,800. Wow, that is a very big number. Lots of arrangements. Okay, calculate the probability that there will be 5 learners between the 2 youngest learners in the line. Okay, right. So let's see. The 2 youngest learners. Okay, so there's pretty much... Okay, so there's 10. There's 10 learners, okay. There's going to be this block of people, of 5 people, and the constituency of that block can change, but we'll get to that. For now, let's just treat it as a monolith. Right, so we're going to have 5 people inside a block. We're going to have the 2 youngest learners, so Yangi number 1 and Yangi number 2, right? And then we're going to have 3 other people. So other person number 1, other person number 2, other person number 3. Right. And these guys are fixed, right? The youngest person is the youngest person. There's no 10 options for the youngest person. There's only 1 option. And the second youngest person is also, as far as we know, right? We haven't been told that there are actually 3 people that are exactly the same age, but we want to know the probability of 5 people being between 2 of those 3. Like, we don't have that complexity. We're just assuming that the youngest person is the only youngest person. They aren't exactly the same age as anyone else in the group. Hey guys, it's in my head. It's not coming out through my mouth. I feel like as I age, my articulation is just becoming more and more pop. But I hope I'm making sense. That for the 2 youngest learners, we have exactly 2 people that we are considering. It's not 5 people that happen to all be the same age and they happen to all be the youngest. It's just 2 people. So, right, so that's what I mean by saying that there's just 1 option for this slot and there's only 1 option for that slot. Right. So we want to arrange these items. Okay, we're just going to dehumanize them for a second here, such that and figure out, okay, in how many of these arrangements is this block between these 2. So I almost actually even want to say more specifically, we want to know how many. So even more specific than that, I'm going to treat this as one unit. Right? And then these are the other items that we can play around. And what I mean by that is we can have the other person. Okay, maybe I should make this smaller to play around with it a bit better. Okay, but so what I mean by that is we can have the other person be here and, have two other people there. Or we can have, whoa, 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 whoa. Or we can have the other person starting, and then have the young person and the 5 people in between, and then the other young person. Wait, and what are we saying also? Okay, so we're saying, so we're saying it's exactly 5 people here. So we're not saying at least 5 learners, in which case we would have to consider, situations where the other person is maybe here. So we don't have to consider that because we're looking at there will be exactly 5 people between these two. Okay, so that's what I mean. So we have this item, this item, this item, which is an interesting item. It's a complex item, and there's also permutations that can happen inside here. We can swap these guys around. We can shuffle these people. Those are all going to create new arrangements. But let's leave that in a black box for now. So all in all, we have 4 items, right? We're starting out with 4 items here. So 4 slots where you can either have other person, other person, other person, or this block, right? So there are 4 factorial arrangements of these 4 items possible. Okay, right. Then we need to think about what's going on inside here. So for each of these 4 factorial arrangements, we can create, there's 2 variants, if I can call it that, right? There's the variant where the youngest person is first, and then, oh no, do I want to start with that? Okay, so first let's start with moving these 3 items around. So we could either have, no, we can't move the 3 things around, sorry. Because the 5 people have to be between the 2 youngest people. Okay, so there's actually only then 2 variants, right? So it could either be, we have O201, Y1, the 5 people, Y203, or we can have O201, Y2, the 5 people, and then Y1, and then O3. So what I mean by that is, okay, for every arrangement we have here, there are then 2 options. It's either then the young person number 1 is first, and then young person number 2 is last, or young person number 2 is first, and then young people, hey, right? So so now there's now 8 arrangements possible, right? The not 8. What is 4 factorial? 24. Is it? Yes, it's 24. Okay, so there's 48 arrangements now, where we're just looking at the 3 other people that are just floating around, the 2, and the position of the 2 young people relative to the 5. No, okay, that's not making sense, yo. Counting dribbles me, and it's then reasonable to expect that it's also gonna dribble me to explain. But I really hope that somewhere in the midst of my rambling, there's some sense. Anyway, then we also need to consider that, okay, for any of these arrangements, right? So suppose we have other person number 2, other person number 1, young person number 1, and then there's the 5 people, and then there's young person number 2, and then there's other person number 3. So for this arrangement, for example, there's then how many different ways we can arrange the 5 people in here. For each arrangement of this, we are creating another arrangement of this, right? So we could have A, B, C, D, E. That is going to be one arrangement here. Then we have the same setup, except now we swap the B and the A. That's going to be another arrangement. And then we have the same setup, except now we swap the D and the E, right? So for each arrangement that's possible here, we are creating a whole other arrangement for the line where the conditions that were stipulated are met. So we are going to then say, we're going to times this by 5 factorial, because 5 factorial is the number of ways that we can arrange 5 people. Right, and that's all that we have to consider. So let's just recap what's going on here. So 4 factorial counts the number of ways that we can arrange 3 people and a group of 7 people. Okay, so group of 7 people is going to be one item, and the 4 factorial then counts how many ways we can arrange these 3 floating people and a group of 7 people. And then 2 is counting the number of ways that we can have y1, y2 ordered. So it could either be y1, y2, or it's going to be y2, y1. So that one's pretty straightforward. Then 5 factorial is counting the number of ways that we can rearrange the people in this block. And then altogether, this is telling us how many different ways it is possible for us to have 5 people between the 2 youngest learners. Right. Yeah, I'm not fully confident in that explanation, but amen. My philosophy is that the more videos I make, hopefully the better I'll become at explaining certain things. Bear with me, and of course, if you have a better explanation, share it in the comments, share it in the comments, share it in the comments, share it in the comments. Okay. Right, and we're looking for a probability. Okay, so the probability that there will be 5 learners between 2 youngest learners is then 5,760 over that big millions. So it's not a very good chance, honestly. And I am not going to rewrite that number. Right. So very tiny chance. Okay, so it's gonna be 0,001587 as a percentage. That is 0.16%. Wow, like it's pretty much 0. Right. Let us check with the memo. Memo, what do you have to say? What do you think of our efforts? Whoa. The memo thinks our efforts are pop. Oh, my darling. Where did we go wrong? So they counted these manually. Chisalena, go bohloko. Okay. So let's try and I'm gonna first try and find the flaw in my reasoning, and then I'm gonna try and understand how the memo has gone about it, because they offer 2 options, 2 approaches. So let us see. So they have a much bigger probability. So they have 322,560 out of 10 10 factorial. So let me just see what's the factor difference here. 56. Okay, so their probability is 56 times higher than mine. Okay, so I'm missing something very significant here. Okay, so I'm saying that I mean, I have a suspicion. So first we put 5 people into a block. And how many possibilities are there for those 5 people? So it feels like, okay, yeah, I feel like I've just counted, what have I counted? The stress of it all. Okay, let's try to think with a clear brain. Let me stop singing and laughing. Okay, right. So, I have counted the number of ways. Let me just rearrange this so that my OCD can rest. Okay, so this 4 factorial is counting the number of ways that we can arrange 4 items. Okay, and then the times 2 is saying that for each arrangement of those 4 items, we could either have this item first and then that one last, or this one first and then that one last. And then the times 5 factorial is now saying for each of the arrangements of the items, the 5 people in here could be shuffled. Okay, but now what it's not counting is the fact that these 5 people are not fixed. We can choose that the people that are chosen to, either the people to go into the block or the people that stay outside here, those people are changing. So, okay, so I need to count what are the different ways of choosing the people that go in here, because then, yeah, okay, I understand. Okay, so what's going on is we are saying all that I've counted is, yeah, I'm gonna need to bring some letters up in here, not letters. I'm not making hamburgers here. Letters. Okay, I'm gonna get rid of this guy. Just relocate these ones temporarily. Okay. Do 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 Okay, so if we have our class is A, B, C, D, our learners E, F, G, H, I, and J. Those are our 10 learners. Okay, so now suppose our two youngest learners are A and J. Okay, right? And then we choose, well, okay, yeah, and then suppose we're just looking specifically at the case where these 5 are between them. Okay, how many possible arrangements are there where that happens? So what I would say is okay, so it would be these guys are a unit, and then the rest of the guys are just free agents. Okay, so then what's gonna happen is there are 4 factorial ways that I can arrange these 4, right? Because yeah, this is not gonna play out the way I wanted to play out, but anyway, we could either have G first, or H or I, or this group, or and then in the second slot it will either have H, I, or this group. So let's just say we have I. Okay, and then in the third slot we'll have either H or this group. So let's just say we have the group. I need to stop avoiding the group. Okay, we're just gonna shrink it to its tiniest. All right, and then in the last slot we'd only have one option left. There'd only be the H left. Okay, right, so that's where the 4 factorial is coming from, right? Is the fact that, okay, there are 4 factorial ways to arrange these 4 items. Okay, then now within an arrangement of these 4 items, A and J can be switched around to create another arrangement. So that is where the times 2 is coming from, is we could either have A and then J, or J and then A. Okay, and then furthermore, within an arrangement, we can also shuffle these 5. So that's where the 5 factorial is coming from. It's coming from the fact that within the group, keep my colors consistent. Okay, there are 5 slots, and there are the 5 people we've already chosen, B, C, D, E, and F. So we could have F over here first. There's 5 options we can choose from. Then we're only left with 4 options, so I can choose D here. And then we're left with 3, I could choose B. And then we're left with 2, so it's between C and E, I can choose E. And then the last slot, I only have 1 option left. And so yeah, so that's the 5 factorial. It's the fact that in the first slot there's 5 I can choose from within this group, and then 4, and then 3, and then 2, and then 1. Right, so all of this is only counting the number of arrangements if I have chosen these guys to be in my group of 5. What about the fact that instead of D here I could choose H, or instead of F I could replace it with an I, right? So I need to also count the number of ways that I can choose the 5 people to begin with, the 5 people that go in here. And by counting the number of people that go in here, I'm also now, I don't have to separately count the number of people that go in here, because by choosing the ones that go in here, I'm also choosing the ones that go out here. Okay, so we are counting how many ways it's possible to choose 5 people from a group of 8. Because remember, A and J are not options. Those are the 2 youngest learners. They can't also be between themselves. Okay, so from the 8 remaining learners, in how many ways can I choose 5 learners? You? Okay, so from 8 learners, choose 5. And the order doesn't matter, right? Because that's already kind of accounted for over here. This is where we're playing around with the order of those 5. So I guess we could get rid of this and just say, in how many ways is it possible to arrange 8 learners, and that would also then take care of the 5. Anyway, it doesn't make sense to my brain to do it that way. I like to, fragment my thinking a bit more. Okay, so from 8 learners, choose 5. So there's 8 factorial. Wait, okay, my brain doesn't think like this either. So we're saying there's 5 slots, and we want to choose 8 learners. And choose means order doesn't matter. We're just picking A, B, C, D, E, E, D, C, B, A, same potato. So, okay, so for the first slot, we have 8 options, and then 7, and then 6, and then 5, and then 4. So these are the possibilities, and then we need to remove our dependence on the order, right? So we need to account for the fact that A, B, C, D, E is the same as B, A, C, D, E is the same as B, A, D, C, E, etc. So the number of ways we can shuffle 5 things is 5 factorial. And yeah, I mean, we're going to times by that 5 factorial again. So anyway, side note. Right, so what does this give us? I'm guessing this is going to give us 56. What am I doing? Five factorial is 120. It gives us 56, man. Mean. Okay, right. So then we need to revise this one. Okay, to say the number of arrangements possible where there are 5 learners standing between the 2 youngest learners. That is going to be 4 factorial times 2 times 5 factorial times 56. So that's 322,560. Okay, which is then going to affect our probability. Okay. What is that? It is 0,088. Wait, there's so many numbers there. Okay, 0,08888. It's 8,89%. I know that 8 over 9 is equal to 0,8 recurring. So 0,08 recurring would be 8 over 9 divided by 10. This is me just trying to see if it's the same as the fraction that is in the memo. So this is 8 over 9 times 1 over 10. So that is indeed 4 over 45, which is what is in the memo. I could also have tried to convert it out. Right. We could just use our calculator. I mean, I think that is something I say far too often on this channel. But anyway, okay, so that was such a yummy question. Oh my gosh. I need to practice my counting. But yeah, the answer in the memo makes so much sense to me. And I think in my future counting questions, I definitely want to try just physically playing with the elements where possible. I mean, yeah, it's gonna be awkward if they're like, there are 1 million letters. I can't write out 1 million letters, there are only 26. Okay, guys, thank you so much for tuning in. It brings me great joy whenever I see the 1, 2, 3 views on these videos. It makes me so happy. Worse when there's a like. Worse, and the day when I go onto YouTube Studio and I see there's 1 more subscriber, I'm just like, hooray! This is making sense to someone out there, I'm hoping. Anyway, cheers. And that's it for this paper. Unless, of course, you would like me to look at a different question that I haven't covered, or a question that I have covered that you think, hey, baby girl, can you just take it from the top again? That is something I would absolutely be very happy to do. So, yeah, let's leave it at that for today and chat again another time.